So picking up right where we were in the last video, we have this reaction of acetic acid, that's CH3COOH aqueous, plus ammonia, which is NH3 aqueous, turning into, CH3COO minus, which is acetate, plus NH4 plus aqueous, which is ammonium. So what happens is the H plus gets donated, or the proton gets donated from the acetic acid to the ammonia. Okay, and what that means is that in this reaction, we have a proton donor, which is the acid, and we have a proton acceptor, which is the base. So that fits the definition, the Bronsted-Lowry definition of both an acid and a base, an acid being a proton donor and a base being a proton acceptor. Now, if we look at the other side and we run this reaction in reverse, which happens all the time in chemistry, the reverse reaction, so going this direction, we can see that the NH4 now has the extra proton, and it will donate one proton back to the acetate. So that means that the NH4 plus is the acid and the CH3COO minus is the base. And you all see how these are related to each other, the acid and the base? The acetic acid is related to the acetate, and the NH3 is related to the ammonium, and they are related by a single proton, and they are what we call conjugate acid-base pairs. The conjugate acid-base pairs are species, chemical species, that differ by only a single proton. So if you think of the word conjugate, I know when I was in high school I took Spanish for a foreign language, and I learned in there what the word conjugate means, because you have to conjugate your verbs, right? Like, oh gosh, I can't think of one. Estoy, or estar means to be, right, in Spanish, and then estoy means I am. So you conjugate the verb. Those two words are very closely related, and they mean essentially the same thing, but in a different context. So conjugate acid-base pairs are very closely related, but differ by just a single proton. So again, NH3 and NH4 plus are a conjugate acid-base pair. And acetic acid and acetate are another conjugate acid-base pair. They differ by only a single proton. So I guess I can write that out rather than just circling it. So acetic acid and acetate are one conjugate acid-base pair, and NH3 and NH4 plus, ammonia and ammonium, are a, whoops, let's fix that, that should be NH4, are another conjugate acid-base pair. And when we look at this, one thing to keep in mind is that the acid in the pair, the acid always has the extra proton.